Okay, so we know that a circuit is a complete loop that allows electrons to pass through it, and in the process of doing so, they transfer energy. In order for them to move, though, you have to have materials called conductors. Usually, metal is the most common type of conductor. There are a variety of different metals, and each metal can conduct electrons or electricity in different ways. So you have conductors that transfer electrons and energy. You also have insulators that protect or cannot transfer electrons or energy. So one example of a good relationship between conductors and insulators would be something like a screwdriver or any other rubber-handled tool. The actual metal piece of this is metal, which means it could conduct electricity. So let's say that you were working on a light socket or a light fixture or something like that, and the power was on. First of all, you should never do that because I've never done that before. But if you were working on it and you accidentally put this metal piece of the tool in contact with a live electrical source, this is going to start conducting some of those electrons, which means that this is now conducting electricity. If you touch this component, you get shocked. If you're touching this rubber handle, though, this plastic or rubber handle, neither one of those materials can conduct electricity, which means that if you're holding this piece and only this piece when that metal comes in contact with an electrical source, you're not going to get shocked by holding this. Over time, the plastic or the rubber will start to melt, but it's not going to shock you. Now, wires work kind of the same way. Wires have on the inside a piece of metal that's usually pretty flexible and bendable. And on the outside, there's a rubber coating that insulates that electrical current. And the reason we do that is so that way if these lines ever come in contact with each other, you're not crossing lines or crossing the electrical current. It keeps them separate from each other. Now, when it comes to wire, there's two types of wire that we'll work with throughout the course of this module. One of them is considered solid core because it's made from a single metal wire, solid core. You're going to use a lot that looks similar to this one. This is called a jumper cable. It makes it easy for us to plug into a breadboard, which we'll talk about in one of our upcoming videos. The advantage of a solid core wire is that it's easy to move and to plug in and take out of something like a breadboard. One of the downsides, though, is that if you bend it too much, it could break. Because over time, it's like if you were to bend something and wiggle it back and forth, you end up creating kind of a crease, and that creates a weak point that allows it to snap. To fix that, there's other mechanisms like this motor, which would be harder to fix the wire for, and it has something called a stranded wire. A stranded wire is lots of smaller, thinner wires that are put together inside one insulator, inside one of these rubber tubes. The advantage is that they're very flexible, which means that they're easy to move and to attach to different things. But one of the downsides is that they're so flexible that they don't go into those breadboards very well. We'll use a variety of these mixed together in order to create functional circuits. Now, when we're talking wire, there's different gauges. You can measure the thickness of wire based on its gauge. And the smaller the number, the larger the wire, which means that it can carry more electricity. So for example, in our walls that supply our lights, our switches, our outlets, things like that, you're using probably a 12 gauge wire. We're going to be using 20 or 22 gauge wire, which means it's thinner, which means it carries less electricity and is therefore safer. Now, whenever we're using wires, they're actually color-coded for specific reasons. Traditionally, red wires indicate a power source or a hot wire. These are the wires that are carrying the electrons from its source to whatever fixture or device is utilizing that power. Black wires typically indicate the neutral, the one that carries the electricity back to the original source. When we code, or when we create circuits rather, it's going to be important to have a color system. It doesn't have to be red or black, but some functions, some fixtures rather, will already have a red wire on here. That's going to be the one we want to connect to the power source. The other color is the one that will return the electricity back to its end destination, so to speak. The important thing is if you ever use different colored wires like this yellow one, that you know which one is carrying your power supply and which one is returning the power to the source. So that way when you go to edit your circuits, you'll be able to do so relatively quickly. Take a look at the next video to learn a little bit more about how we measure electricity.